All right, now that you've got your CFA Learning Target 6.2 returned, I wanted to make sure that you understood any questions you may have missed. The first type of question has to do with when you're in the lab. And we measured 16.8 grams of carbon, 4.24 grams of hydrogen, and 11.2 grams of oxygen in this sample of ethanol. And so the first thing, in order to find percent composition, we need to know the total. So we have to actually add up all of the values. So I'm going to do that in the column 16.8 plus 4.24 plus 11.2. And so I need to add those together, 16.8 plus 4.24 plus 11.2, and I get 32.24. That's important because we know that the entire compound has a mass of 32.24 grams. Now to figure out the percent of carbon, I know that I had 16.8 grams of carbon divided by the whole thing times 100%. Putting that in my calculator, I get approximately 52.1%. Sorry, my 100% doesn't look like 100%, does it? So that's how much carbon I have. Hydrogen, I had 4.24% or grams of hydrogen divided by the entire compound, which was 32.24 grams, times 100% is approximately, to three significant figures, 13.2% hydrogen. And then for oxygen, I had 11.2 grams. 11.2 grams divided by the entire amount. It's a part to whole percent times 100% to three significant figures is 34.7% oxygen. So that's how you do a percent composition if you know the mass of each element. Now, let's say I already know the molecular formula. Then I know that I would take 9 times, I have 9 carbons, so 9 times 12.01 is equal to 108.09. So I know that's how much carbon I have. I know I have 8 hydrogens. 8 hydrogens, 8 times 1.01 is 8.08 grams of hydrogen in a mole. I assume basically take one, let's say I have 1 mole of aspirin. And then I have 4 oxygens. 4 times 16 is 64. All right. Now, I need to add all of those up to get the molar mass of aspirin. So if I take 108.09 plus 8.08 plus 64 and put that in my calculator, I get 180.17. And so in each of these cases, I'm timesing it by 100% to get the percent composition by mass. Once I do that, I get 59.993% carbon. And I guess because this is the molar mass, we're just doing the molar masses that we see on the periodic table. We don't necessarily need to, if you've rounded this to 60%, that's fine. 4.48% 4.48% hydrogen, and this is approximately 35.52% of oxygen. That is the percent composition by mass in aspirin. Now it says, what is the empirical formula? Empirical formula is the lowest ratio. I see 6, 8, and 6, they're all even. So if I divide them all by 2, 6 divided by 2 is 3, 8 divided by 2 is 4, and 6 divided by 2 is 3. I can't reduce it anymore. For sodium peroxide or sodium oxide, I have Na2O2, and so this is actually a different type of peroxide. So Na2O2, that's a 1-to-1 ratio, so I divide them both by 2, and I have NaO. That's the empirical formulas that give the lowest ratio. Now, if I know percent composition by mass, I can find the empirical formula by, remember, step 1, I change everything to grams. So for, I say 49 grams of carbon, and then I have 2.7 grams of hydrogen and 48.2 grams of chlorine. That's my first step. Assume I have 100 grams. Now I divide them each by their molar mass. Carbon is 12.01 grams per mole of carbon. Hydrogen is 1.01 grams per mole. And again, I have a lot of these memorized. Remember, the molar masses are these numbers here. Hydrogen, of course, is 1.01. Chlorine, that halogen is 35.45. That's where I'm finding these values. The molar masses are on the periodic table. All right, so this tells me the grams divide out, and then I get moles. So I have 49.0 divided by 12.1 is about 4.08 moles of carbon. 2.7 divided by 1.01 is about 2.67 moles of hydrogen. And then the chlorine, 48.2 divided by 35.45 is about 1.36 moles of chlorine. Now remember, the next step is to look for the smallest number, which is 1.36, so I'm going to divide them all by 1.36 to get the ratio. Again, we're trying to find the ratio of these atoms, carbon, hydrogen, and chlorine. This I know is 1 mole of chlorine, because that's going to be 1. 2.67 divided by 1.36 is approximately 2. And 4.08 divided by 1.36 is approximately 3. So my ratio is 3 to 2 to 1. So my equation would be, my empirical formula, I have a subscript 3, subscript of 2, and a subscript of 1 for chlorine, and you don't actually write the 1. But that's how to find the empirical formula if you know the percent composition. The next problem was, if you have the empirical formula and you know the molar mass, what's the molecular formula? So the first thing you have to do is find the molar mass of the empirical formula. Well, carbon is 12.01. Fluorine is 19.00. Bromine, fluorine and bromine are both halogens. Bromine is 79.90. And hopefully by now you know that oxygen is 16. When I add all of those together, I get 126.91. So once you know this is the molar mass of the empirical formula, we know the molar mass of the compound is 509.4 grams. I divide that by my empirical formula mass to figure out how many empirical formulas are in the molar mass. Well, 509.4 divided by 126.91 is 4, approximately 4. Therefore, I need to take each of these subscripts, which happen to be 1, and times them by 4. So my molecular formula will be C4, F4, Br4, and O4. And finally, if I have epinephrine or adrenaline, and I know that it is 59% carbon, remember the first step, I change that to grams. 7.1% hydrogen, change that to grams. 26.25% Oxygen, change that to grams. Assume I have 100 grams of substance and 7.65% nitrogen, change that to grams. First step I'm going to do is divide them each by their molar mass. 1 mole of carbon has 12.01 grams. Hopefully you know that by now. Sorry, I don't want to divide out the 12.101, just the grams. And then hydrogen, I'll put grams twice. 1.01 grams of hydrogen per mole of hydrogen. Again, the grams of hydrogen divide out. Oxygen is 16 grams of oxygen per mole of oxygen. Grams of oxygen divide out. And 1 mole of nitrogen is 14.01 grams. Again, I'm getting all of these values from the periodic table. Turns out that 59 divided by 12 gives me 4.91 moles of carbon. 7.1 divided by 1.01 is 7.03 moles of hydrogen. 26.25 divided by 16 is 1.64 moles of oxygen. And 7.65 divided by 14.01 is 0.546 moles of nitrogen. The smallest value is 0.546. So I divide them all by 0.546 to find out the ratio of moles in epinephrine or adrenaline. When I take 4.91 and divide it by 0.546, I get 9 moles of carbon. 7.03 divided by 0.546 is 13 moles of hydrogen. 1.64 divided by 0.546 is about 3 moles of oxygen. And then, of course, this is just 1 mole of nitrogen. So my empirical formula is C9H13O3. Again, these become subscripts, and N1. I don't need a 1 there. Now, what I need to do is figure out what the molar mass of this is. So I do 9 times 12.01 plus 13 times 1.01 plus 3 times 16 plus 1 times 14. And it turns out that when I add all of those together, I get 183.23 grams. I know that the molar mass of the substance is about 183 grams per mole. So of course, if I take the molar mass and divide it by the molar mass of the empirical formula, I get 1. So therefore, my molecular formula is equal to the empirical formula, which is kind of nifty. But if this had been a 2, I would have had to multiply these by 2. If this had been a 3, I would have had to multiply all of these subscripts by 3. All right, I hope that helps you understand the CFA so that you are ready for the summative.